Okay, friends, you have a second video. Oh no, that you had to click on two different buttons. Sorry, I'm very annoyed about this. I got a phone call. It wasn't a telemarketer. It was my doctor telling me I tested positive for COVID, which I already knew. So he said he would call me yesterday. He called me today. Uh, Continuing on with where we were in the video. So I need to share screen, AirPlay, share, jump into this, share to Zoom, which it takes forever to figure out. Okay. All right. So, yes. So I believe I was saying to y'all that people want me to give them an exhaustive set of formulas here. Look for, if you're in degrees, the closest multiple of 180. Subtract big number from little number, and you'll get the reference angle. When we do it in radians, look for the closest multiple of pi, subtract big number minus little number, okay? And then you get a positive number. So here, since we have 200 degrees, the nearest multiple of 180 will be actual 180. So the reference angle will, in fact, be 20 degrees, all right? Then for the other one of 7 pi over 12, well, 7 over 12 is slightly more than 1/2. So the angle we're thinking about is in here, roughly. And the nearest multiple of pi is going to be pi, not pi over 12. People somewhere get this misapprehension that it has something to do with the y-axis. It never has to do with the y-axis. It is always the x-axis, always multiples of pi, not pi over 2. So here, I'll have 7/12 pi minus pi. Well, that obviously is going to give me a negative number, right? Of negative 5 pi over 12. But the question says, or the description says, that you need to get a positive angle. This is going to be super complicated. I just reversed the two of them. And now suddenly the answer, instead of being negative 5 pi over 12, is positive 5 pi over 12. Okay? Nothing complicated. Big number minus small number gets you positive. It's always just a multiple of 180 or a multiple of pi, depending on what your measurements are. So now y'all try the same thing. And you'll note that for the first one, it's 75 degrees, which would be in here someplace, okay? So 75 degrees, the nearest multiple of 180 is 0 degrees. So the reference angle for 75 degrees is just 75 degrees. In fact, anything in the first quadrant is always its own reference angle, right? Now, 11 pi over 6, on the other hand, that's going to be 11 6. It's not quite 12 6. So it's going to be somewhere down here in my fourth quadrant. Draw it about like that, okay? And so the closest multiple of pi is going to be 2 pi. Remember, big minus small, so 2 pi minus 11 pi over 6 So 2 is going to be 12/6. So we end up getting pi over 6 radians. Okay, that's it. All right. So our next thing that we have to talk about here is going to, you know what? I ought to add another page. So let me add a page here and say something briefly about these trig functions. If we are not talking about trig functions with right triangles, then any angle that you're talking about, you can take any point on that angle and get the x and y coordinates for it. And of course, if you draw a right triangle down there, this length along the x-axis is x, this length along the y-axis is y, and this length on the hypotenuse we go ahead and label as r. If you got x and y, you figure out r by using the Pythagorean theorem. Actually, if you got any two of them, you can figure out the other, right? So keep that in mind. So if this is an angle, and I wrote my theta too small, this is an angle here, theta, then we can talk about sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta, really in short order by talking about the x and the y and the r on these. Okay, so you're expecting me to say something about the opposite and adjacent and hypotenuse, right? But now we're replacing the opposite side with the coordinate y and the adjacent side with the coordinate x. The difference is x and y could be negative depending on what quadrant that your angle ends up in. So when we say the sine y, it is sine theta, it's y over r, and the cosine is x over r. Tangent is y over x, and my y over x. My cosecant is going to be, remember, cosecant and secant are reciprocals of sine and cosine, respectively. And so it's just flipping things over again. And then the cotangent is just the reciprocal of tangent. And so you get x over y. Okay? So keep these in mind as we go along here, right? So you'll encounter some problems where they say you have an angle in a given quadrant. Now, for the quadrants, we know that the first quadrant has positive x and positive y. Second quadrant has negative x values. Fourth quadrant down here has negative y values. And this third quadrant has negative on both the x and the y values. Okay. So we are told here that we've got a sine theta being 12/13, right? So that means when we want to set up an angle that we're thinking about for this, that it needs to be pretty far. Oh, and I started to draw it in the wrong quadrant. Second quadrant, and it needs to have the 12/13. So that means that it has to be a fairly large angle that we're thinking about there. And I'm going to draw, let's see, maybe I'll draw red here, this little arc where we're pointing over here to the angle. So that's the angle that we're really thinking about. Now, you are allowed to pick where you want on this. Since it has 12/13 as a sign, you are allowed to pick a triangle that has the hypotenuse being 13 and the opposite side there, the y coordinate being 12. Okay, so we're really just thinking about, we've got this point here. We don't know its x coordinate, but we know the y coordinate is 12. Okay, and we can figure out the x coordinate. So figuring out this x coordinate here, we'll just go and say x squared plus 12 squared equals 13 squared. And you can go do that with a calculator, but I did it ahead of time. So I would get that, and my x squared then turns out to be 25. That means the x is either plus or minus 5. But look where it's at. It's in the second quadrant. That means that the x has to be -5. So x equals -5, right? Now we're going to just fill in everything here. Please notice, I did not take an inverse sign. That's not the point of these problems. We are figuring out, based on the geometry of what's happening, what these values would need to be. We knew the 12/13ths to start for sine, and now we know the cosine needs to be -5/13. And the tangent needs to be negative, which is at 12/5. And then for the reciprocal functions, the cosecant is going to be 13/12. The secant is going to be -13/5. And the cotangent is going to be -5/12. And that's that, right? So basically you figured out what that x coordinate was and then just fed it into things. And all the reciprocal functions, you just go ahead and take reciprocals. Good? Great. Thanks. All right. Then on this next one here, we're doing the same thing. Okay. We know that we're going to be in quadrant 4, and the cosine needs to be 3/5. So that means we'll have something, maybe, let's see, about here. And we're going to have the point where it's 3, y. We don't know what the y is. And we'll have this hypotenuse being 5. We're going to go and say that 3 squared plus y squared needs to be 5 squared. And then y squared equals 25 minus 9 is 16. And so y is either plus or minus 4. But look at where it's at. It's totally -4, right? So then we'll put y equals -4. Okay, you can totally have examples where they're positive. I just chose 2 examples where they were negative because those are the harder examples. Okay, so then you fill out all the trig functions. And cosecant theta, secant theta, cotangent theta. So which one did we know originally? The cosine, that was 3/5. And by the way, that meant that we knew the secant was 5/3 without doing anything. But now -4/5 says -5/4. And your tangent is -4/3. And then the cotangent is -3/4. All right, cool. All right. Okay, so this one here asks us to fill out the chart using exact values without using a calculator. All right. So the thing that you need to do is to figure out your reference angle first. And the sine, cosine, and tangent will be the same as the reference angle, except for a plus or minus. Okay. So if I look at 2 pi over 3, my first one here, I know that 2 pi over 3 is actually an angle here in the second quadrant, right? And I can say that the reference angle, 2 pi over 3, is closest to pi. So I subtract and get my reference angle is pi over 3. And I know without doing anything, this is just stuff we ought to have memorized, that the sine of pi over 3 is square root of 3 over 2. The cosine of pi over 3 is 1/2. And the tangent of pi over 3 is the square root of 3. Okay? Now I need to figure out pluses and minuses based on the quadrant it's in. So notice in this quadrant, the x coordinates are negative, but the y coordinates are positive. And in the definitions that we just got a minute ago, we know the x coordinates go with cosine. So that says the cosine's negative, but the sine is positive because the y coordinates are positive. Since tangent is y over x, those are negative anytime the x and y coordinates have different signs. So tangents are positive in the third quadrant and the first quadrant, but negative in the second quadrant and the fourth quadrant. Okay, so that gets that one there. All right. Then let me erase that one. And let's get another one there, right? So for 5 pi over 4, 5/4 is more than 1, but it's less than 3/2. So 5/4 is actually going to end up being here in the third quadrant, right? And so for the reference angle, we're going to take the 5 pi over 4, and we're going to subtract pi from it. Pi was the closest multiple of pi. Get pi over 4. Now, if we'd gotten something negative, we just reverse the two of them, okay? But pi over 4, I know without looking it up, as a sine of square root of 2 over 2, a cosine of square root of 2 over 2, and a tangent of 1. Then, because in my third quadrant here, my x and y are both negative, that means my sine and cosine are both negative, but my tangent is going to be positive because the x and y, when you divide them, cancel out the negatives. Good. All right. So let me go ahead and take that piece there out. And now we're looking at 11 pi over 6. So 11/6 is pretty close to 2. So that's going to be an angle about here, okay? And so it's in the third quadrant, and the closest multiple of pi is going to be 2 pi. And when I subtract 11 pi over 6, I'll get pi over 6, okay? So pi over 6 is one of our special angles, and its sine is 1/2. Its cosine is root 3 over 2, and its tangent is 1 over root 3, okay? Then for figuring out the pluses and minuses, I look and see that we are in the fourth quadrant. The thing with the x's gets a positive, and the thing with the y's gets a negative. that means that I will get a positive here for the cosine, but a negative for the sine. And because the signs were different, SIGN, the plus and minuses were different, and then the y divided by x, the tangent, will end up being negative as well. Okay, cool. All right. Finally, we have these questions here. So if it says that cosine theta is this positive number here, and I should make my greater than sign a little better. If cosine is positive, that means our x coordinates have to be positive. That means that we are in quadrants, and we have to look. X's are positive in the first and fourth quadrant. So in quadrants 1 or 4. And the next one has sine theta being negative, right? That means the y coordinates need to be negative. So we're looking at these two possibilities. So that means quadrants, where was it? 3 or 4. Okay. And the last one says, what if the tangent theta is positive? So tangent theta is this positive square root of 3. What's important is that it's positive. And that means that the pluses and minuses need to be the same between the x's and y's. So both positive or both negative. So this one is in quadrants. That's right, quadrants. Quadrants 1 or 3. Okay. All right, that's got us taken care of. I think this will handle everything. Sorry, I'm a little bit fussy here. I'm doing well health-wise. It's just that I may be contagious. So I think I get to come back on Tuesday. So look forward to another one of these videos for Monday. But after that, I should be back. Okay. All right, folks. See y'all later. Remember, there'll be Zoom links that will come up for the office hours. I'll send those out as soon as I get them figured out. Thanks.